Okay, scientific notation. Scientific notation was developed by the science community. And so Roman numeral 1, scientific notation. And one of the reasons it was developed in the science community is that there's certain things that we measure that are either super big or super small. So, for example, a very large number would be the population of Richland, 75,000, give or take. If you were trying to use the population of Richland to, say, estimate how much water we're going to need in the next year, you would want to know about how many people, 75,000. Now, if we wait 3 minutes, a baby's born at Cadillac, we're now 75,001. If you wait 10 minutes, an older person will pass away, and now we're back to 75,000. So past a certain amount, the number is so large that we don't really care about +1, -1. We just need overall to know what's the bulk of the population. And that's what scientific notation does, is it chops off the unnecessary numbers or numbers that change too frequently to be accurate anyway. Scientific notation is also used with really small numbers, like trying to measure the width of a cell, how big a cell is. You know, that's a really, really small number. And again, it's so small that there are slight variations in cell size, just like slight variations in people size, but they don't really care about +1 inch, -1 inch. They just want to know generally how big are the cells. So that's where scientific notation fills a gap and it makes it more practical. Okay, so the format for scientific notation is some number C times 10 to the power of n. And you can tell this is a science thing because they used an X for a time symbol. Whereas if this was algebra, we'd use a dot. You have to use the X for the time symbol. That will mess with your head because you guys are algebra students, but that's how it is. N is a positive or negative integer. Of course, integer means whole number, plus and minus. C has to be less than 10, greater than or equal to 1. It cannot be smaller than 1 or greater than a 10. Okay, so example 1, 2.5 times 10 to the -8. And you're going to be asked to evaluate. Sometimes instead of evaluate, they'll say write the number in standard form. And both of those things mean write it without the exponent. Just write the number. Okay, so here's where what we've been learning with exponents crosses over into this. 10 to the -8 means that 2.5 is being divided by 10 to the +8. That's what the negative exponent means. So we're going to divide by 10 to the 8th. And what's important is that you recognize that when you divide by 10 to the 8th, your number should get smaller. The biggest problem with scientific notation is students can't keep it straight. Which way do I move the decimal? So you need to take a second and go, should my number get bigger or smaller? And that will tell you which direction. So every time you divide by a 10, the number changes by a factor of 10, which when we write it means the decimal appears to move 1/10 to the right or to the left. So put 2.5 over here. If we're going to divide by 10 to the 8th, this number is going to get smaller. In fact, the decimal will move 8 tens to the left. So we move 1, and then, oops, we don't have any more numbers. So we start to fill with zeros. So that's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Let me make sure I've got the right number of zeros here. 1, 2, 3, 4, 5, 6, 7. Nope, I don't. There we go. So to make the number smaller, we went left 8 places. So our number is and it should have, I did it again. I erased a 0. Sorry. Should have 7 zeros on it. I got to put my glasses on. So 1, 2, 3, 4, 5, 6, 7 zeros and a 2.5. And you'll notice this is a lot smaller than 2.5, which makes sense because we divided it by 10 to the 8th. All right, let's do another example. 1.73 times 10 to the 5th. And we're going to evaluate or write it in standard form. So if I write this like an algebra student, this is 1.73 times 10 to the 5th, which means that my number, so we're going to multiply by 10 to the 5th, and our number is going to get bigger because we are multiplying by 10. So our number should get larger, which means we're going to move the decimal to the right 5 places because our number should be getting bigger. So here we go. 1.73 is where we start. And now we're going to multiply by 5 tens. So move it 5 places. 1, 2, 3, 4, 5. We have to fill 3 zeros. And we end up with 173,000 or 173,000. And again, you're multiplying by tens, so the number should get bigger. And 173,000 is a lot bigger than 1.73. Okay, so now we're going to do the backwards process. So on example 3, we've got the number 3,140, and we're going to put it into scientific notation. Okay, so first thing you need to do is place the 0 where it belongs. Remember that your C value has to be less than 10, greater than 1. Now, I'm going to use a pencil. Don't write what I'm writing, okay? I'm using a pencil. If I put the decimal here, I now have 314. That's way bigger than 10, so that's not where it goes. If I put the decimal here, I'm now 31.4. That's still bigger than 10. That's not where it goes. If I put the decimal here, now I've got 3.14. That is between a 1 and a 10. So that's where your decimal is going to be in your answer, is 3.14. Now, the way you have to think about this process is you're going to place the new decimal, which we just did, remembering that C is less than 10, greater than or equal to 1. And here's where you're going to figure it out. You're going to count back to the original place. Count back to the original place. If you count to the right to get back to the original place, your exponent is positive, and it's going to be times 10 to some positive number. If you have to count back left, that means that your power of 10 will be a negative number. Now, in this case, for me to count back to where it was, the invisible decimal was here, I have to go 1, 2, 3 to the right. So right means positive. So I'm going to have times 10 to the power of 3, because I had to go 3 to the right to get back to the original number. The other way you can kind of logically think about it is 3.14 is smaller than 3,140. Nod your head if that makes sense. Smaller. So to get from 3 to a 3,000, the number has to get bigger, which is why it's got to be a positive 3 for the tens. Does that make sense? Smaller to bigger means by positive power. If you can keep that in mind, this is not confusing. That's the thing that confuses people, is if they don't think smaller to bigger, bigger to smaller, it can get weird. Okay, let's do example 4. 0.000365. We're going to put this into scientific form or scientific notation. All right, so where does the new decimal need to be? So the new decimal needs to be between the 3 and the 6, because 3 meets the requirement of less than 10, bigger than 1. Okay, so we got that part. Times 10. Now here's where we got to figure out how to get back to where we started. Here's where our new one is. We have to go to the left, 1, 2, 3, 4. We have to go to the left 4, which means we have to get smaller. So it's going to be 3.65 times 10 to the negative 4, because 3 is bigger than 0.000365. So we have to divide by 10 to go back to the small number. Okay. Example 5. 23.4 times 10 to the power of 5. What is wrong with this number?
It's not in between 1 and 10.
That's right. It's too big. It's not between 1 and 10. So this one we need to fix. Many of the math processes we're going to do with scientific notation, you will have to fix the format at the end, even if you use a calculator. You'll have to fix it. So how do we fix it? Well, like just what we did. My decimal needs to be between the 2 and the 3. That way it's between 1 and 10. Now count the places to get back to the original. To get back to the original, I have to go 1 to the right, which means I have to get bigger. So this is going to be 2.34 times 10 to the positive 1 to get back to where I started. You can put 10 to the 1 or just put times 10. Both are correct for scientific notation. In the beginning, you might want to put the 1. Okay, Roman numeral 2. You need to be able to multiply or divide in scientific form. It's a pretty simple process. The first step, you multiply or divide the C's. And then here's where our exponent rules come in. You're going to multiply or divide the exponents, and that's going to use your exponent rules. And then you may or may not have a third step. You have to look at what you've got. If it's good the way it is, you're done. If it's not following the rules of scientific notation, you're going to have to fix it. So the third step is fix if needed. And sometimes it will be needed and sometimes it won't. Okay, let's do an example. We're going to do 1.2 times 10 to the 11 times 2 times 10 to the 4th. All right, so to multiply, you multiply the C's. So I'm going to go 1.2 times 2, which is 2.4. And then you're going to multiply the 10s using your exponent rule. So 10 to the 11th times 10 to the 4th is 10 to the 11 plus 4, which is 10 to the 15. That's just your simple multiplication rule. And now we look. The power is positive, that's good. And 2.4 is between 1 and 10, so we are done. All right, let's do a division example. 1.21 times 10 to the 11th divided by 1.1 times 10 to the 4th. Okay, the basic approach is the same. You're going to divide the C's. So you're going to go 1.21 divided by 1.1. When you do that, you get 1.1. Okay, now we're going to do the 10s. So it's going to be 10 to the 11 minus 4, top exponent minus bottom. 11 minus 4 is 7, so 10 to the 7th. And our C value is between 1 and 10, so we do not need to fix that one. All right, last one, and then we're done. We're going to fix, let's say that you've got 12.1 times 10 to the negative 3. Obviously, 12 is not between 1 and 10. So I need to put my decimal between the 1 and the 2. And now I got to figure out, what do I need to go back to where I started? So the decimal was here. So to get back to it, I have to go 1 to the right. So I'm going to multiply by 10 to the positive 1 because I have to go 1 to the right to get the original number. So that means you're going to use your multiplication of exponents. So 1.21 times 10 to the negative 3 plus 1, which is 10 to the negative 2. So if you're fixing a number in scientific notation, put the decimal where it belongs, figure out what you need to do to go back to where it was. We needed to go 1 to the right, and that tells you if you're going to multiply by 10 to a positive number or 10 to a negative number. Depends if you're going to the right or the left. This one was to the right, so it was a positive 1. Multiply those together. Questions about that?